Hello, my name is Elizabeth Aguirre, and this is our current source on our VCO. So this right here is a subcircuit for part A. This is our op amp. This is our transistor that we'll be using, and then this is our potentiometer that we use as the voltage divider to on the op amp. And so here, our transistor, specifically the current at the collector, is equal to the current at the emitter. And so here we can say that this transistor is in saturation mode for the purpose of the rest of the circuit here. And so if we come here to our IV curve that we've plotted as a response of changing the voltage input, we see that as we increase the voltage, our current is decreasing. So for part B, here we have our Schmitt trigger subcircuit. And so here together we see that these two resistors are our R1, and this one is our RF, which is what we use. And then here is the potentiometer. So if we take a look at what the diagram looks like, we see that here we have our RF and our R1. And so the potentiometer controls what the voltage at Vref is. And so if we look at this diagram, we can explain what a Schmitt trigger does. So here we have a varying signal, and similar to a comparator, once the signal passes a certain threshold, so for example, the comparator is the red line, the comparator will switch up in response to that. However, a Schmitt trigger has two different thresholds, and so it's less responsive in that it doesn't alternate its output as much as a comparator does. And so we can see that when it goes up past this threshold, this Schmitt trigger responds, and then once it passes down here at the second threshold, the Schmitt trigger also changes. So altogether here we have our completed VCO circuit. So once again, here we have our current source. Here, this is our Schmitt trigger. Over here is our current mirror, and then here we have our inverter. And this is the capacitor, which we measure the voltage at node A. And then here is our output of the Schmitt trigger. And so when we look at the graphs, we can see here, here VA is plotted and VO is plotted. So VA, which is the voltage at the capacitor, we see charges and discharges at the same rate, which can be explained by the current mirror that we have attached to the VA node A on the circuit. And then here we have our response of our Schmitt trigger. And so we can see that it functions according to the thresholds that we have for it. And then if we take a look at our VN versus the frequency at VO, we can see how the circuit responds. So as our VN increases, our frequency decreases at VO, and so we can say that the circuit is truly dependent and it is voltage controlled, a voltage controlled oscillator.